Good morning. I'm going over the lesson on pages 47 and 48 about solving quadratics. So today you're actually going to learn a little bit more about how to use your calculator in solving quadratics. So let's begin with the notes on the top of today's lesson on page 47. It says the zero of a function is a value of the input, x, that makes the output, f of x, equal to 0. Remember, f of x is the same thing as saying y. So you're looking for whenever y is equal to 0, essentially. The zeros of a quadratic function are the x-intercepts and are also called the roots or solutions. So that's just kind of repeating what we already learned. So moving on, our first example. Find the zeros of f of x equals x squared plus 3x minus 3 by using the graph below. Now I do understand the graph is a bit faded, but we can just literally count squares to get our roots. So beginning at the origin, which is right here in the middle, I'll mark it. I'll find our first root on the left side, which is at negative 1, 2, 3. So our first root is at negative 3. And our second root, starting from the origin, is over here at positive 1. Reminding you that the roots are wherever your parabola crosses the x-axis. So we have two roots. I can write it a couple of different ways. I can write it in set notation with the brackets like I have over here on the left. I can write it as a set of points. Negative 3 comma 0 is a coordinate. And the other coordinate would be at 1 comma 0. Remember, because y is equal to 0 on this graph. So that's another way I can write it. Or I can also say x equals negative 3 and x equals positive 1. That's in equation form. So there's three different ways, and we're going to be practicing and using these various ways on today's assignment. So our next example down here below says find the solutions of the function f of x equals x squared minus 2x minus 15 by using the table below. Our definition above says the solution, the roots, the zeros, whatever you want to call it, is wherever the function f of x equals 0. F of x means y. So wherever this column equals 0, we have our roots. And here we go. We have negative 3, 0, and again down here at 5 comma 0. So our roots, we can write them in a couple of different ways. I'll go ahead and write them just in coordinate form, since that's already the form they're given to me on the table. Negative 3 and 5 comma 0. Since it wasn't specified, I can write it any way I want. Now here is the crux of today's lesson, the calculator part, the part that you guys have probably been waiting for to learn how to do, if you don't know how to do it already. So it says find the roots using your calculator. So for today's lesson, I'm going to go ahead and get our Inspire. Now I do most of my work through Scratchpad, which is when you press this button on the left-hand side. That's like a little calculator. So I'll go ahead and press it once, and then here I get a blank screen for calculations. If I press it again, I get a blank coordinate grid. Let me go ahead and let this focus, since it's a bit bright on my screen right now. There we go, it's a little better there. So our first equation, that's underneath my calculator, they give us is x squared plus x minus 20. So you still need to be able to find the roots for this. And I just realized that I don't even need the graphing part. So I'm gonna go back to the calculation part. Okay, so now backtrack, here we go. Sorry about that. So here we go, we have our equation. Our a value, our a coefficient is 1. Our b is also positive 1 because you have a single x. And our c is negative 20. Once I've identified my a, my b, and my c terms, now I can go ahead and in Scratchpad, in the calculation side, not the graphing side, although you could do it that way. Here's today's trick, and I have it written above. You're going to press menu, and then it's option 3 for algebra, that's the class we're in, option 3 for polynomial tools, and the very first option that pops up, finding roots of a polynomial, because that's what we're doing, 1, and then it says degree. Well, the highest exponent we have in any of our equations is a 2, second degree equation. So it's already set to that, so you never have to even change that. Just go right to OK and press enter. And it's going to ask you basically for what's your A, your B, and your C. It's written a little differently here, but this is what it means. So your A value, we said, was a positive 1. So I'll put a positive 1 in that first box and then down arrow. My B value was also a positive 1. So I'll enter a 1 in that box and also down arrow. And my C value is a negative 20. So I'll go ahead and enter negative 20 in that final box, down arrow to where it says OK, and then I'll go ahead and press enter. So it basically is asking me, do you want me to find the roots for you for x squared plus x minus 20? And yes, we do. So just press enter again. When you do that, your roots will pop up in set notation. negative 5, comma 4. So you get negative 5, comma 4, close your set, and those are your x's, and move on to the next problem. So try this again. Remember, it's menu 3, 3, 1, and then OK. Menu 3, 3, 1, and then just go down arrow to OK. You need your a, b, and c terms. So for the second equation, it's 1x squared, so a 1, with the negative 9 for the negative 9x, and an 8 for the term at the very end. So 1, negative 9, 8. I could go ahead and enter that 1, negative 9, down arrow to 8, down arrow to OK, and press enter again to verify. And in this case, the solution we get is a little bright, but it is 1, 8. So there's our next solution. And if you do the next one, the final one, correct, you should get a solution of 1, 2. So today, you're going to be practicing the menu 3, 3, 1, OK method over and over again for the TI Inspire. A bit of a review on this next example on the front page. Find the square roots. Notice it's plural. So now we need two answers, multiple answers. So for example, what square root or roots would, what is the square root of positive 4? Well, we know it's positive 2, but it's also negative 2. Because negative 2 times negative 2 also gives you a positive 4. For 25, we know the positive square root is 5. There's also a negative square root. So we can say plus or minus 5, or positive 5 and negative 5. You can use that plus minus symbol. The square root of 1 would be plus and minus 1, or plus 1 and negative 1. Both of those numbers times themselves will give you what's underneath the radical symbol, the 1. What number times itself will give you 100? We could also say negative 10 times itself, comma, positive 10. And go ahead and write kind of like that. Now, here, very specific question. The square root of what number would have a root of positive 6? And that would be a positive 36. Because 6 times 6 gives you a positive 36. In that case, we work in reverse. What would 7 times 7 give us? That would be a 49. The square root of 49 equals 7. Now, let's go ahead and go to our next example. Notice I have some stars here because there's also some important bits here we have to talk about. So, solve the following quadratic equations. You still don't need your calculator yet. Just use a bit of logic. What number times itself would give you a positive 1? Well, we can get negative 1 and a positive 1. Both those numbers times themselves will give us a positive 1. What numbers times themselves will give you a positive 25? And if you haven't figured out already, negative 5 times itself will give you a 25, and positive 5 times itself will give you a 25. Our final example, what number times itself will give you a positive 10? Well, for that one, you have to work a little backwards. What I would just do for this one, I'm going to go ahead and just give it to you, is going to be, actually, I just remember now, this was a misprint. It's supposed to be 100. We're missing a 0 there, because I knew we weren't going to do radicals just yet. So what number times itself gives you 100? And there we go, negative 10 and positive 10. So please make sure to fix that error. There is a missing 0 that's been cut off. Now finally, we're going to go back to using our calculator. Remember, in order to use the calculator function menu 331 OK, you have to have your equations in standard form. That means all your equations have to be equal to 0 or maybe equal to y. But they can't